optical amplifications, a ray of light strike a mirror with an angle of incidence and get reflected with angle of reflection equal to the angle of incidence. When the mirror rotates through an angle theta, the angle of incidence changes to I plus theta. Before rotation of the mirror, the angle between incident rays and reflected rays is 2I, and after rotation it is 2 of I plus theta. Obviously, there is angular magnification of 2 theta between the incident and reflected rays. In order to get a greater magnification, more number of mirror surfaces may be used. When you are saying about the examples, the principles to amplify the input signals, which is used in the following cases, are to be the optical levers, UV galvanometers, mechanical pointer and galvanometers. The last one to be the electrical and electronic amplifiers. The electrical amplifiers which are used to increase the magnitude of weak voltage or current signals resulting from electromechanical transducers. The next topic is about filters. So what is filtering? Actually, the filtering is the process of alternating unwanted components of a measurement while permitting the desired components to pass. So actually, we'll have the filter is an electronic circuit, this which can pass or stop a particular band of frequency through it. The filter was first designed by G.A. Campbell and D.Z. Zogel at Bell Laboratories. So the band of frequencies which will pass through the filter is called pass band, and the band of pass band will pass without suffering from any attenuation, while the band of all remaining frequencies of attenuating band will be superset completely. And what about the classifications of filters? Actually, the classifications can be on two different types. One to be the on the basis of passing and attenuating of frequencies, and other one to be the relation between series and shunt impedance. So, on the basis of passing and attenuating frequencies, we'll have four different types of filter. One to be the low pass filter, second one to be the high pass filter, and third one to be the band pass filter, and the fourth one to be the band stop filters. And similarly, when you are saying about on the basis of relationship between series and shunt impedance, we'll have two different types, constant K filters and M-derived filters. So what is low pass filters? Actually, these process are those filters which pass only low frequencies through them and which reject out high frequencies above the cutoff frequencies. A low pass filter is also called a lag network because it has a phase lag in the output signal. This type of filter is also called integrating network. What about in the case of high pass? There are those filters which pass only high frequencies through them and which reject all low frequencies below the cutoff frequencies. The high pass filter is the differentiating network and it is also called lead network because it will cause a phase lead in the output signal. What about band pass filters? These are those filters which pass a band of frequencies through them and which reject all other frequencies through them to pass. The final one to be the band stop. These filters, which are also known as band elimination filters, which reject a band of frequencies to pass through them and which allow the other frequencies to pass through them. Okay, then let's just think on the basis of relation between series and shunt impedance. So the constant type filters can be otherwise named as an prototype filters. In these filters, the series impedance Z1 and the shunt impedance Z2, they are interrelated by the equations Z1, Z2 is equivalent to K square, where K is the constant impedance frequency. What about in the case of an M-derived? Actually, these filters not how the product of series and shunt impedance equal to K square, but how the same characteristic impedance as the corresponding K section with a sharper attenuation characteristic. So actually, some terminology has to be applied to a low pass filters, which are applicable to the high pass and the band pass. The thing is to be over on it. So whereas in the case of an input circuitry, we'll have a simple current and then we'll have about an ballast circuits. We'll have about an voltage dividing circuits. We'll have a bridge circuits and then we'll have a resonance circuits and then finally we'll have often amplifier input circuits. So thank you all.